Hey guys, we are live and welcome to the day before Pure 2 live stream. I have been so excited about doing this because I don't know, I just think in between the papers is such a good vibe because everybody is like ready. We've kind of predicted what topics should be coming up or like expected topics of what we should think about coming up. And like last live stream, what I want to do is start off with a poll of what mantra is going to be winning for tomorrow. So one of these was submitted by somebody in one of my other live streams, and I've come up with some other ones about some marks as well. So I'm going to start the poll. Which mantra is winning for paper 2 tomorrow? Let's hope it works. I'll let you read through those. Hope I've not made any mistakes in those kind of things that we've got there. But we are going to be doing for this live stream, I have picked a set of different questions from past papers. It's probably going to be running between an hour and a half to 2 hours, that sort of amount of time that I'm imagining for this kind of thing. And if you haven't already voted, decide which of these ones you want to vote for which you think is going to be the mantra for tomorrow's. Then a couple of these, you've got to do some maths for these kinds of things as well. So you might want to have a think through and see if you've understood the maths with all of these things that we've got here. The mantras are just a silly kind of thing for this sort of stuff, so I wouldn't worry too much about it. It was just like a little thing for me to keep track of how many people have like jumped in on this kind of thing. I haven't got the Bicen t-shirt on. Do you think I should have the Bicen t-shirt on as like a good luck kind of thing for this? I don't know, maybe I should have the Bicen t-shirt on. If I do, I will probably switch to that in just a second. And I was actually going to tell you something. Okay, everyone's saying yes. I'm going to go and put the Bicen t-shirt on. I'll be back in 1 second. Okay, it's a good luck charm, so we've got to have it on. Okay, I mentioned this about the Bicen t-shirt in another live stream. This was made by a student, and I know a couple of people have actually got this. A couple of people have actually got this t-shirt. I know that they've actually already got this already. But what I was planning on doing, so I kind of want you to like sort of stick around a bit on the channel after I do my third paper release. I'm thinking of doing this. I'd love to know what you guys think. I'm thinking of doing a competition to see like who wants to design like some new t-shirts. And then I was thinking of selling them, but not taking any profit from it at all. Like all of the profit, I was going to split 50-50 between the designer of the t-shirt and a charity of their choice or my choice or some kind of charity that we can vote for. So I thought that actually we could, it'd be kind of a cool thing. We can have a few winning designs that we might have for this sort of stuff. And then people could buy them and it just raises money for the student who designed it. And it also raises money for a particular charity as well. And I think maybe rather than me judging them, someone saying, how would I judge which one wins? I could like post them and like a vote and we could have like the top 5 winning or something like that. And then people can buy them. I don't know. I just think things like that is like a nice way to kind of connect with the community, because this t-shirt is so stupid but so fun, like just the kind of thing. I mean, I don't think people really want merch for a maths YouTuber, but if it's something that raises some money for 17, 18, 19-year-olds, and if it's something that raises money for a charity as well, then I don't see any sort of harm in doing that. So I might give you a little bit of a mini project for you guys to do. So let me talk you through what we're going to be doing in today's session, because I don't want to waste too much of your time because we've got a very important day tomorrow. This is our day before Pure 2 live stream, and I know some of you are probably sick of seeing me. You've been in every live stream, you've been in my in-between Pure 1 and Pure 2 session. You've probably seen so much of me that you'll be relieved to get to the end of the exam season. And after this is obviously going to be paper 3. I ran some sessions for stats and mechanics a few weeks back. If you do want those, you can get them for £15. It's like 2.5 hours plus an extra sort of hour and a half video of some questions going through afterwards. That might be the kind of thing that you need to get prepared for paper 3. I always see on my YouTube analytics a huge spike in all of my applied videos the day that Pure 2 finishes. So I know people are going to be going for that kind of thing as well. Okay, let's actually get started because I don't want to waste too much of your time. We've got like over 1,500 people here, and like so far on the votes, we've already had like 1,300 votes, 1,250 votes, which is amazing. So what we're going to be looking at in the session is we're going to be doing these 9 topics plus a little time for some Q&A at the end of this. So I'm going to kick off with some proof by contradiction. I'm doing a binomial expansion and partial fractions. Obviously, these are things that have not been assessed yet, which is why I've picked them. A question on the quotient rule, a differential equations question, some parametrics, some functions, some modulus graphs, some geometric series and some recurrence series. And at the end, I'll stick around to do the Q&A as well. So this was my list that I had before. This was the list of things that I felt like could be coming up in tomorrow's paper, because these are things that have not yet been assessed. So I will let you read through this. You can obviously come back to the video and pause this thing as well. But the ones that are in the blue writing there are covered in the live stream, and the black ones are not covered in the live stream. So you might want to check over those things. Or I know many of you have already bought this. You might want to get the recording of my in-between Pure 1 and Pure 2 session for only £15, which is a Zoom recording plus a 2-hour video of additional questions that you can try in your own time. And I know probably most of you here have probably got that already, but I have been incredibly sort of blown away by the response to that. And that's all linked in the description for that kind of stuff. There's still time to do it before tomorrow's exam as well, okay? So implicit differentiation, I think, is actually included here. Yeah, implicit differentiation is included. I'm just not covering it in today's session, okay? And then the session that if you want to get the in-between session that's paid for, it's not with questions that are from past papers from our specification. It's from like international. I've written some of my own questions, all sorts of stuff. Whereas when I do the live stream, I just do the official past paper questions for this as well. So let's kick off with proof by contradiction. Now, you know the standard things for proof by contradiction. The first thing that we need to do is we need to assume the opposite is true for a contradiction. Assume the opposite is true. That's for a contradiction. And then what's the second thing that we do after we assume that the opposite is true for this? I always say what I kind of do for this stuff. I wonder if there's a way I can actually turn off the ads. I didn't mean to put the ads on for this part that we've got here. So maybe I can just, I wonder if I can change it here. Yeah, I'm going to turn off the ads. Great. That's actually not that bad to do. So let me just save that. So you shouldn't be getting disturbed during this. Good. Yeah, my second point here is just to do some maths. And some of those are easier to spot than other for that kind of thing. Doing some maths might be adding some things together. It might be doing a fraction. It might be factorizing, but just do something. And then hopefully that should lead you to something else. And then what we do here is that means that we find some sort of contradiction. And what's the final bullet point that we need to have after we have found the contradiction that we won't get for we won't get the last mark unless you do this? Very good. We obviously need to have our conclusion statement. Now, I've actually picked one that is like a specific proof that almost needs to be memorized for this. But of course, in my session, I go through some other ones. And if you came to my Aiming for A-star sessions, which are also reduced to £15, all the stuff is linked in the description. I do quite a lot of proof by contradictions in one of those sessions as well. So we're going to do a classic one, which is to prove by contradiction that the square root of 5 is irrational. And they've started doing these things where they've written these additional sentences to try and make the proof become a little bit easier. So here it says, you may use the fact without proof. If n squared is a multiple of a, then n is also a multiple of a that we have. So I'm going to begin by starting off, and I'm going to write down that I will do the opposite. I will assume that the square root of 5 is rational. In other words, the square root of 5 is equal to a over b, which is a rational number, where a and b are non-zero integers. If you don't say non-zero, it's perfectly fine as well. And we need to say, and they have no common factors. And they have no common factors. You can also say that they are co-prime if you want to. That's a different way of saying this. But that's just the general setup that we have for this kind of thing. So we know what we need to do for this kind of stuff. We're going to square both sides. That's the only maths you can possibly do to this thing. You've got to do some maths. So I'm going to do the squaring of both sides. So that 5 is equal to a squared over b squared. And then if I keep doing some maths with this, 5b squared is equal to a squared. So what does this tell me then about a squared? This tells me something about a squared if it's equal to 5b squared. And yes, Ben, you can just say that they are in their simplest form, that a over b is in its simplest form here. They do have a common factor of 1, but we can ignore that. So this means that a squared is a multiple of 5. And this is where we can use the part that's highlighted in yellow. So if a squared is a multiple of 5, then a is also a multiple of 5. A squared is a multiple of 5, and so a is also a multiple of 5. Which means that a is equal to 5k, because it's a multiple of 5. So I can take that and I can now substitute it back into this part, so that 5b squared is equal to a squared, like this. So 5b squared is equal to 25k squared, which means that b squared is 5k squared. So this tells me that b squared is a multiple of 5. And so b is also a multiple of 5 because of that yellow proof. And so, whoops. And so b is also a multiple of 5. As a and b are both multiples of 5, they have a common factor. So we have a contradiction, because we said that they didn't have a common factor. So we have a contradiction, terribly written at the end. Hence, we need to do the conclusion statement, the square root of 5 is irrational. Now, the reason why this works is because if they are both multiples of 5, you're like, okay, that's fine. Why can't we just divide it by 5? Well, if you said, okay, that means that instead of it being written as a over b, we've divided them both by 5. You don't need to do this for the proof. This is just me doing a bit of teaching here. If I divided this by 5 and this by 5, so we got some new fraction so that it was c over d, we could do this entire process again, and we would show that c and d are both multiples of 5, which means you could write it as e over f. But then you could keep doing this infinitely. You could keep simplifying by dividing by 5 every single time, which is not possible for a fraction. There is no fraction that you can infinitely cancel down like this. So that's why this common factors thing is a real sort of crucial part that we have written in that part that we've got there, okay? So that was a little one on proof by contradiction. I do feel like if proof by contradiction comes up, it's very likely to come up around like question 13, 14, 15, 16, like that kind of end part of the paper. I've said to some students that you might like to kind of have a look at this as like, because I find people get a bit tired by the end of the exam. It's the kind of thing that if you're like, I can normally do proof, but I run out of time, you might want to kind of flick to it, do it earlier on, and then you've always got it to kind of try afterwards as well, okay? So let's continue. We're going to have a look at some stuff with binomial expansion and partial fractions. Now, they haven't assessed anything on partial fractions just yet, or binomial expansion, and they always have both of these things. So I found a question from a few years back that actually combines partial fractions with binomial expansion. The only thing I'm going to write down is our formula for binomial expansion here. We need it in the form, let's go back to my normal blue color. We need it in the 1 plus x to the power of n form. So our binomial expansion that we're going to have goes 1 plus nx plus n minus 1 over 2 x squared. And then there'd be those future ones that we've got there as well, okay? So what are we going to do for these parts? Let's look at part A of this question. So question 9 says, we have got that f of x is 50x squared plus 38x plus 9 over 5x plus 2 squared, 1 minus 2x. And it says, given that it can be expressed in this form where a, b, and c are constants, find the value of b and c, and then show that a is equal to 0. So we've got partial fractions here. And the thing I just wanted to alert you to is that if they didn't give you this form, we notice that there is a squared part here. When you do this with a squared part, you obviously have to write it with the non-squared part, and then also with the squared part afterwards. This is just kind of one of those standard things that we might have in these things, okay? So what we're going to do is partial fractions. I'm going to begin by writing that my 50x squared plus 38x plus 9 over my 5x plus 2 squared, 1 minus 2x, can be written in the form a over 5x plus 2 plus, getting a bit messy here, let's tidy this up, plus b over 5x plus 2 squared plus c over 1 minus 2x. So we need to make everything on the right-hand side have a common denominator, and that common denominator is going to be this thing. So the thing that a is going to get multiplied by, well, to get to the 5x plus 2 squared, we obviously need there to be an extra 5x plus 2, and we need there to be the 1 minus 2x. The b has already got the 5x plus 2 squared, so it needs to be multiplied by a 1 minus 2x. So the b needs to be multiplied by 1 minus 2x. The c has already got the 1 minus 2x, so it just needs the 5x plus 2 all squared. Now, if you can tell me in the chat, I know there are lots of methods for doing this. I'm going to do it with the substitution method. What are the values I'm going to need to substitute in for this kind of thing that we have here? Sir Obi says, what would it be if it was 5x squared plus 2 squared? You actually wouldn't get that kind of thing in a normal maths paper. That's only going to be in like a further maths kind of paper. So the things we're going to be substituting in, we've got a half and the minus 2/5 for this. So I'm going to start off, let's let x equal a half, either as a fraction or as a decimal. I'm going to just type it as a decimal. I find it easier to type. So when I do 0.5, I'll store it in my calculator. I will do 50 answer squared plus 38 answer plus 9. So the left-hand side is 40.5. And when I substitute in a half, that part is going to go and that part is going to go because of the 1 minus 2x bits. So the only thing is going to be left is this part. So that's 5 times by a half plus 2 squared. So that is equal to 20.25c. And 40.5 divided by that gives us that c is equal to 2. Okay, now we're going to let x equal the minus 2/5. Just for ease of typing it in my calculator, 2/5 is 0.4. I just find it easier typing in decimals. So I'll do minus 0.4. I will do 50 answer squared plus 38 answer plus 9. Left-hand side is 1.8. When I substitute in those bits, it means that this 5x plus 2 will disappear. This part here is also going to disappear. So I'm just going to be left with 1 minus 2 times minus 0.4, which is 1.8b. So I get 1.8b for this. Let's get rid of those highlights so it doesn't confuse too much about what's going on in this question, okay? And then our last part is to figure out, obviously b is equal to 1. We need to show that a is equal to 0 for this kind of thing. So what else can I do if I'm going to do like a substitution kind of question for this? Because I've already done those kind of substitutions that we've got. This should be like a 2-hour session, maybe an hour and a half. You can do comparing coefficients, or you can substitute in a different value. I'm going to do something easy. I'm just going to substitute in x equals 0. If you do further maths, you're probably used to doing comparing coefficients. So I get 9 equals. Subbing in 0 just means I can ignore anything with the x. So it's just the 2 times 1 times the a. And then I get a plus b when x is 0. And when x is 0 at the end, I get a 4c for this part. So 9 equals 2a plus b plus 4 times 2, which is 8. 9 equals 2a plus 9, and so a is equal to 0 in this part. Now it does just say find the value of b and the value of c. If it said to express something in partial fractions, what would I need to do at the end of the question? It doesn't say it here, it just says find a, b, and c, but what would I need to do with this? Yeah, and if you do a simultaneous equations method with this and you still get a equals 0, that's absolutely fine to do as well. Yeah, at the end of it says express it in partial fractions, you do need to rewrite the question and show that it is written in partial fractions like this thing here. And then we get binomial expansion. So it says use binomial expansions. Notice how they want us to do more than one of them here to show that in ascending powers of x, f of x is p plus qx plus rx squared, where p, q, and r are simplified fractions to be found. And then we're going to find the range of values of x for which the expansion is valid. So I think what I probably want to do for this question, as well as adding in a spare page for this, is I want to say what the thing is we're actually doing it to. It's this thing here. We just said that a was 0, so that part is going to disappear. So it's going to be b over 5x plus 2 squared. So b is 1. So it's going to be b over 5x plus 2 squared. And then the last part was c over 1 minus 2x. That's c over 1 minus 2x. So when I do binomial expansion, I'm going to do it on these two separate pieces and then add them together. So I'm going to start off with this one. This is my 1 over 5x plus 2 all squared. Obviously, I'm going to rewrite this so that it's written as 5x plus 2 to the power of minus 2. But I'm going to do one more stage of rewriting. What do you think I'm going to do as some rewriting for this part that we've got here? What do you think I might do for this rewriting stage that we've got? No, careful. I'm actually going to do what May said. I'm not going to divide by the 5. They might have tricked you with this, okay? We're actually going to take out the 2. So I need to make it look like the normal way that it looks. It normally looks like 2 plus 5x to the power of minus 2. So we're actually going to be taking out the 2, not the 5. Remember, it needs to be a 1, not a 1x. So when I take out the 2, it will be a 2 to the power of minus 2, and then a 1 plus 5 over 2x to the power of minus 2, okay? Hopefully that's something that we spotted we need to do. You have to make sure that you're taking a 2, not a 5. 2 to the minus 2 is a quarter. And so I then just have the 1 plus 5 over 2x. In this case, my power is minus 2, and my x term in my formula is 5 over 2x. So I get 1 plus n multiplied by x plus n minus 1 over 2 times by the x part all squared like this. Don't need to go any further for this because it finishes at squared term. So we're just going to stop at this particular part. And this is a 7-mark question. There's a lot of stuff they want you to do in this question. So I will go a little bit slower. I'll do the quarter. I will have the 1 minus 5x. And then for the next part, this is positive. So it's just going to be a positive. So it is going to be the 5 over 2 squared times 2 times 3 divided by 2, which is 75 over 4. So this is plus 75 over 4x squared. And my last step is just to multiply through by a quarter. So I get a quarter minus 5 over 4x plus 75 over 16x squared. And then they want you to do binomial expansion again for this kind of thing. Apart from this time, I'll do it in purple. We'll do it for the 2 over 1 minus 2x. And this one's actually a little bit easier. This is 2, 1 minus 2x to the power of minus 1. Nothing needs to be factored out of this one because there's already the 1 that goes with it, but there's the 2. In this case, our power is minus 1 and our x value is minus 2x. So it will be 2, 1 plus nx plus n minus 1 over 2, the x term squared. I'll leave the 2 out the front for now. That's going to be 1 plus 2x. This is going to also be a plus at the end, and I think it's going to be a plus 4x squared. Yeah, the 2's cancel, and I think that all works out. So we end up with 2 plus 4x plus 8x squared for this kind of thing, okay? So next thing we need to do for this is actually put it all together. We need to just add these two things together because the original thing was being added. So I will take this, and I will add them, which means that f of x is equal to the 2 plus the quarter, the 4x minus the 5 over 4x, I'm collecting them together, and the x squared plus the 75 over 16 for this. Okay, I keep looking at the chat just in case I have made any mistakes for these kinds of things, but I don't think so. So the 2 plus the quarter is 9 over 4. We then have the 4 minus 5 over 4, which is the 11 over 4x. And then the 8 plus 75 over 16, which is 203 over 16x squared. So a lot of marks for this kind of thing that we've got here. The reason we need to do plus, it was because it was written as this, okay? It was written as the first part of it here plus the second part of it. So that's how I knew it had to be a plus for this particular question. We just need to do the last part, which is to find the range of values for which the expansion is valid. Now, we're going to go back through the question and see where we actually did the expansion. Here, we did the expansion on the 5 over 2x. So for this part of the question, we are saying that 5 over 2x, I'm going to need another blank page for this. We are saying that 5 over 2x has got to be less than 1. That's how we do this for binomial expansion, which means that the magnitude of x has got to be less than, you do the 1 times the 2 to get 5x. I'll tell you what, I'll do it slightly slower. So when I double both sides, we get this. And when I divide by 5, we get this. And from the second expansion, we did the second expansion at this stage on the minus 2x. This means that the modulus of minus 2x is less than 1. Well, modulus around negatives means it doesn't really matter. So I can just write it like this. I can half both sides, and I get this. Now, this is where I probably write things as a decimal. That's 0.4, and that's 0.5. So which of these is the stricter inequality? Which of these is kind of like narrowing it down as much as possible for this kind of question? The 0.4 is narrower. 0.5 is a bit wider, and it has to be true for both of them at the same time. So I will say, hence, it is valid for the modulus of x is less than 2/5. If you didn't want to write it like this, you could say that x is between minus 2/5 and 2/5, because if it was, say, 0.45, it would work for this, but it wouldn't work for this, and so the expansion wouldn't be valid overall for this kind of thing, okay? Someone was asking, how do you know like which denominators to do when it's in partial fractions? Well, once it gets written like this, that's going to be a denominator, that's going to be a denominator, but if it's squared, it needs to appear in both kind of forms, in the non-squared form and in the squared form that we have for this kind of thing, okay? So that was a really long question. I will double check we got it all right. So we knew that that part was correct. We had B as 1 and C as 2 and A as 0. And then here, this was the part I want to check. 9 quarters, 11 quarters, 203 over 16. 9 quarters, 11 quarters, 203 over 16. That's perfect. And we also had that the modulus of x is less than 2/5. But if you wrote it like this thing over here, that would be perfectly fine for that kind of stuff as well. Okay? So let's continue. We're going to have a look at some stuff to do with the quotient rule. Now, when we have the quotient rule, this is when we have something like y equals u over v, and we want to differentiate it. You've probably seen me do this loads and loads of times. I will write out what u and v are. I will differentiate them to find u dash and v dash. And you know what I'm going to ask about here. What am I going to be drawing here? What am I going to be saying for this? It's not the picnic table for this kind of thing. This is not the picnic table for this one. It's the alpha shape for this one. So what I mean by this is you're going to do vu dash minus uv dash. That's just how I draw them. I start at the top and then go like this. So this means the formula is vu dash minus uv dash, that branch, minus that branch, and it gets divided by v squared for this kind of question that we have got here. Let's see, by the way, how many people have actually voted on this. We've had 2,500 votes, and it's so nice to see that confidence is proportional to skill, which was contributed by one of the previous previous that has been in one of the live streams. It's nice to see that that is the winning one. But I hope you've checked the maths of all the other ones and that you know that they're all very positive kinds of things that we are looking for. Yeah, Mama Bicen is the person who wrote my mantra is winning, so very, very good. Okay, so let me continue with this. We're actually going to do this question, which looks so innocent, okay? I'm going to show you 3 ways of doing this. I'm going to show you the way that my brain would do it, because I'm not a super creative mathematician. I'm quite a traditional mathematician. I'm then going to show you a slightly more like hacking the question kind of way, and then I'm going to show you this like genius kind of way of doing this kind of question. Okay, it looks so simple, but it's actually not that simple because of the fact that we are already at question 14 of the exam. So I'm going to say here, we're going to differentiate this. I'm going to let u equal x minus 4 and v equal 2 plus x to the half like this. So u dash is just 1 and v dash, well, the 2 differentiates to nothing, but for the x to the half, I will pull the power down and I will reduce the power by 1, and then I'm going to kick off doing the quotient rule like this, okay? So this means that dy by dx is those 2 things multiplied, which multiplying by 1 isn't going to change it, so it's just 2 plus x to the half, and then it's going to be these 2 things multiplied, okay? These 2 things multiplied. So it's going to be this thing times this thing. It's going to need brackets, and it's going to be subtracted. That's the rule of the quotient rule. So it is going to look like this. And as we said in the quotient rule, it also gets divided by v squared for the denominator. So this gets divided by 2 plus x to the half all squared. Now, it doesn't very much look like the thing we're aiming for right now, but we're going to try and see if we can tidy this up. So the numerator is a 2 plus x to the half. Then when we multiply these, be careful, you've got a minus a half and a power of 1. So it's going to be a power of a half. It'll be minus a half x to the power of a half, and then be very careful, you have a negative times a negative. The half and the 4 makes a 2, a positive 2, and it will be x to the minus a half. And I'm also at this stage going to expand the denominator because I can't think of anything else that I can do with this kind of question. So when I expand this, 2 times 2 is the 4. You get a 2x to the half and a 2x to the half, so a 4x to the half. You also then get an x to the half all squared, which is just an x that we've got. So I'll do one more stage of tidying up because this and this are like terms. So I get left with 2 plus a half x to the half plus 2x to the minus the half all over 4 plus 4x to the half plus x. Now this is very hard to spot because it doesn't look like anything is kind of simplifying down at all that we've got here. So one of the ways you could go about doing this question if you get completely stuck, I'm actually going to, no, I'll continue with the way I would have done this because I know what we're aiming for now, but then I'll show you what you could do if you got stuck here, and then I'll show you the really like smart trick that I would never have noticed myself. So to be able to kind of compare these things, I'm wanting it to look like something so simple. I literally just want the denominator to be something to do with x to the power of a half. So if I'm looking for it to be with x to the power of a half, I know that it's going to need everything else is going to need to cancel out entirely. So if I want everything else to cancel out, that means there's going to have to be an x to the half here, and whatever it gets multiplied by, this whole thing is going to have to cancel out with something in the numerator to just leave me with that really simple thing. So I'm going to kind of like force this to happen by factorizing out x to the half from this thing that we would have at the bottom. Very, very tricky thing to do. But if I do this, 4 would have to be 4x to the minus a half. I'm dividing by x to the half, so that times that gives me the 4. There would then be a 4 for the next part, and for the last part, there would have to be an x to the half like this. Now, if I rewrite the numerator, you might spot what's happening. So if I write this one with the power of a minus half, I'll write the power of a minus half first, which is 2x to the minus a half. My next number is just a constant, so I'm just going to write the constant number. And then my last number is x to the half, so I have a half x to the half. And I'm wanting them to cancel out, but they don't quite cancel out. So is there anything else that you think I can do here that can make them, because they look so similar. What I'm trying to do is I hope that this thing and this thing here look really similar. Very good to Ruby there. We can either multiply the top by 2, which we kind of shouldn't do, but we can take a factor of 2 out from the bottom. You can either take a factor of 2, sorry, a factor of a half from the numerator, or a factor of 2 from the bottom. So if I was going to take a factor of 2 at the bottom, it would be 2x to the half. It would then be 2x to the minus a half plus 2 plus a half x to the minus a half, which is exactly the same as the numerator that we have written like this. And so magically that whole thing there and there cancels, and we get 1 over 2x to the half, which is just 1 over 2 root, not root a, 1 over 2 root x, so a is equal to 2 at this stage. I think that is very, very challenging to do this. Now, I'm not going to do the full alternative of this. If we got stuck, right, what we could do is, because we know that dy by dx is equal to 1 over a root x, I could let this left-hand side be 1 over a root x, and then what I could do is multiply up by this whole thing up here. I could multiply up by this side as a root x, and then I could compare coefficients. That would be a way of figuring out like what the value of a was going to be. Okay, so that's one of the ways of doing this thing that we've got. It's a very, very challenging question. By having this thing as like an aiming for, we could actually set dy by dx as equal to that, and we could rearrange all of this stuff here and hopefully find out what it was. Now, I am going to show you the absolute like speed hack of this question, which I don't think I ever would have noticed, but I wanted to share it with you guys just in case. So here is a crazy alternative for this. The original function was y equals x minus 4 over 2 plus root x. Now, I'm going to pretend, right? Not pretend. I'm going to try and do some manipulation to this kind of thing that we've got here. This numerator that we've got. If I wanted to force factorize this into something, can you think about what I could force the numerator to factorize to? I haven't tried it with rationalizing. People are suggesting that you could try that as well. What could you do if you wanted to force the numerator? Muta has got it. I'm going to do difference of 2 squares on the top, which is insane. I'm going to do difference of 2 squares on the top. So it will be a root 2 plus a root x plus 2 and a root x minus 2, which definitely works for the numerator. I'm going to write the denominator the other way around as a root x plus 2. They cancel, which means that y is the square root of x minus 2. In other words, it's x to the half minus 2. And so dy by dx, I will pull the power down. I will reduce the power by 1. It is 1 over 2 root x. Crazy. I would never notice this, but it does work for this kind of thing. Should we really quickly try it with rationalizing the denominator and like see what happens with it? Because people did say, let's try rationalizing the denominator. So this is one that I didn't even see anywhere else in a mark scheme. Let's do this in a green because people have suggested it and I'd love to see if it works. So we have x minus 4 over 2 plus root x. We're going to multiply it by 2 minus root x and 2 minus root x and see what we get. I don't know if it's going to do anything much nicer, but let's try it. So the denominator will just become a 4 minus x. And then actually, we're pretty much ready to go. Wow, this is amazing. This is so good. I'd never thought of this. I'm not even going to expand the top. I'm not even going to expand the top. I'm going to leave it like this. What do you think I can now do? This is crazy. I didn't even think of this. Whoever was suggesting rationalizing the denominator, I think is absolutely brilliant. So the numerator is the same as the denominator, but with a negative sign as well. So if I factor out a -1, I get 4 minus x, 2 minus root x over 4 minus x. The 4 minus x is cancel, so that I'm just left with minus 2 minus root x, which is root x minus 2, which is exactly the same process that we had at this stage over here. So it finishes up with the same thing. So I called this whole section, right? I called it quotient rule. But you know what we probably should have called it is like difference of two squares or rationalizing the denominator. So all those people who suggested rationalizing the denominator, that was an absolutely brilliant method for this 4 marks question that we've got there. That was kind of fun going through that and seeing all these different ways of this. I don't even think they've suggested doing rationalizing the denominator, but exam technique stuff, right? If you could only get to this stage and you couldn't do that final bit of simplifying, look, 3 out of 4. You only lose 1 mark for doing that final stage of it. So don't stress yourself too much. If it's about trying to do that last stage of these kinds of things, really, really don't stress yourself too much with this kind of stuff. Okay, vote update. We've had 2,922 people vote. And it looks like confidence is proportional to skill is going to be the winner. I kind of loved that as the winning one, especially as it wasn't one that I came up with for this as well. So we will do a differential equation question, and then I might go and get myself a bit more water. I always drink so much water in these sessions. I am using GoodNotes to do all of this stuff. So for differential equations, we know if we have something like dy by dx equals something like xy, we need the y variables to go on the left, and we need the x variables to be on the right. So the only way I can get this y variable to the left is by dividing, like this. And that dx that I've got that's in the denominator is going to go to the right by multiplying up like this. And once we've got it written like this, we just go straight in with the integration. And of course, when we do that integration that we've got there, we will have a plus c. But when we do the plus c, I'm probably just going to put it on the right hand side. I feel like it makes sense just to put it in one single place for this kind of thing that we've got there. Okay. So I have found a question that actually I think is something that really could be coming up. When I did my in-between Pure 1 and Pure 2 session at the weekend, and I know tons of people have bought the recording for that. If you're interested in it, loads of information in the description when you go to that event, only £15. I was really focused on this idea of the differential equations question being with partial fractions. But I actually feel like this is a differential equation question that could definitely be coming up in tomorrow's paper because it is trig modelling with differential equations. So it's 2 areas that again haven't been assessed yet. I'm classically thinking it's going to be partial fractions and differential equations, but this one is trig modelling and differential equations, which is a really solid pairing of things. So I think this is a classic one that's going to tick off a bit of our trig modelling kind of stuff as well. So the integration in this one is not crazy, but we've got a bit of stuff to do with modelling that might be a bit more challenging in this question. So it says that the height above ground, h meters, of a passenger on a roller coaster can be modelled by this differential equation, where t is time in seconds from the start of the ride. Given that the passenger is 5 meters above the ground at the start of the ride. I don't know if anyone else does this, but as soon as I see that, I go, okay, h equals 5 at the start of the ride, t equals 0. And then I just kind of forget about that sentence. It's not useful. The only thing I want is h equals 5 and t equals 0. So you know what to do. dh dt is h cos 0.25t divided by 40. And I want to get the h stuff to the left, and I'll leave the t stuff on the right. So to get the h stuff to the left, I need to divide by this h so that I get 1 over h dh. And then this dt part is going to come up to here. If you wanted to, you could also put the 40 on this side, but I personally just think it's fine to stay on this side. So I have the cos of 0.25t. Instead of writing it as divided by 40, I personally don't like it like that. I think it makes more sense to write it as 1 over 40 with the dt at the end, and then I put the integration signs in with this kind of stuff that we have, okay? So let's continue. We're actually going to do the integration now. The left-hand side is pretty simple. It's going to be ln of h with those modulus signs. Now, I'm going to ask you in the chat what the right-hand side integrates to, and I'm going to go and fill up my glass of water. I feel so bad. 2,200 people just watching a stationary screen of nothing happening there. So I agree with loads of these answers I'm seeing. I'm seeing as a 10th sine of 0.25t plus c. Now you could either write it as a plus c, you could write it as plus ln. I think just doing it as plus c at this, instead of lnk, I think c is perfectly fine for this. And I probably would just double check to see that this works. So it would be a 10th multiplied by the 0.25, and sine differentiates to cos, and a 10th times 0.25, yep, a 10th times a quarter, that is 1 over 40, so I know it's definitely been integrated correctly. Now, that was that fact that we have here. H is 5 and t is 0. H is 5, t is 0. ln 5 equals, yeah, you can put it in your calculator if you want to. I'm not going to put it in my calculator because I know that when t is 0, the sine of 0 is 0. So c is ln 5. In other words, ln h, gosh, too many straight lines going up and down there. I'm going to write that a bit more carefully. ln of h equals a 10th sine 0.25t plus ln 5. Now, I personally, when I have ln's, like 2 ln's like this kind of stuff, whoa, that is a huge super chat there from Krishna M. That is absolutely very, very kind of you and incredibly generous for you to have done that. Thank you so much. Wow, that's amazing. That is so cool. Okay, so I got distracted by that. That was awesome. What I'm going to do now is, when I see these ln's, right, I personally just like to combine the ln's right away for this kind of stuff. Okay, I like to combine them straight away. So I'm going to have the ln of h minus the ln of 5 is a 10th sine 0.25t, because I just know that ln's, when you can put them together, it's just so simple. So I have the ln of h over 5 is a 10th sine 0.25t, and then my final stage, checking what I'm trying to aim to, is obviously going to be with this e part that we've got here, and they've changed it from a 10th to 0.1 as well. So this means that h over 5 is e to the 0.1 sine of 0.25t, and because of that, divide by 5, it now gets really easy, really simple, that it is just 5e to the 0.1 sine 0.25t for this question. I would be really happy if that kind of question came up for this sort of stuff that we've got here, okay? So what are we saying here? That's very nice. That's so cool. Okay, great. So what I'm going to do is continue with this question, and we're actually going to do the actual modelling part. It now says to state the maximum height of the passenger above the ground that we've got here. So you could have continued with part B even if you couldn't do part A. Now, if I want this whole thing to be as big as possible, well, naturally, I want the E part to be as big as possible, which means I want this part at the top to be as big as possible. So what is the biggest thing that this can be? What's the part I'm going to be in? There we go. Mateo's already said it. I don't know if anyone else said that as well. It's when sine is 1. So the max height is when the sine of 0.25t is equal to 1. We're trying to make it as big as possible. So the height, which is a maximum, is going to be 5e to the 0.1 times by 1, which is just 5e to the 0.1. which is 5.53 meters to 3 significant figures. And I think that sounds reasonable. 5 meters for a roller coaster. It's not like 1,500 meters, which is not realistic. And it's also not like 20 centimeters. So it feels like it's a realistic kind of answer for this. And then for part C, it says the passenger reaches the maximum height for the second time. This is an incredibly important part of the question. T seconds after the start of the ride. Find the value of t. So we just said it occurs when sine of 0.25t is equal to 1. This means when you solve this, 0.25t is the inverse sine of 1. If you can do this without a calculator, then I like that. It's pi over 2, but that would only correspond to the first time. And they want the second time that we've got here. So the second solution that we get for this is you have to plus 2 pi. 2 plus a half is 5 pi over 2. So we now have that 0.25t is 5 pi over 2. 5 over 2 times 4 times pi. T is 10 pi. I'm not even going to type that in my calculator. 31.4 seconds. So T, capital T, I suppose I should say, because they were talking about capital T, but you don't get penalised for that, is 31.4 seconds to 3 significant figures for this kind of thing here. You don't have to know the exact truth values, it's fine for this. Very good question from Fletcher. Fletcher said, why don't we have to do pi minus the answer? Well, if I did do pi minus the answer to get a second solution, I do just get the same solution. I do just get pi over 2 for this. So the only option was to add 2 pi to this kind of thing, okay? To the person who's just done the super chat, to Saki, when you switch the limits when integrating, do you remove the negative fully or you just take it out as a constant? No, you just fully remove it. So that if you did have something that was like 3x minus 2 between a and b, it would change to b and a, 2 minus 3x. In other words, I've negated the inside thing, okay? That's how we do that kind of thing. So you notice how the middle part, I've negated this, meaning they've swapped over. That's what happens when you do this. So going back to this question, let's double check that we've got all of this correct. We have the 5.53 meters, they would condone the lack of units, and then 31.4 for this part that we've got here. And of course, we're going to do something with parametrics in just a second here as well. We've still got over 2,000 people. This is absolutely crazy for this kind of stuff. I'm so happy that people come to these sessions. I would love to know, by the way, I would just love to see how many people in the chat who has either got the recording or like come to my session. I'm hoping there's like a big group of people that have either used my session. I hope you have found it useful. That would be absolutely amazing if it's something that you guys have found useful. Whoa, that is insane. There's so many people. That is so cool. I love that. Yeah, I'm hoping you've got no adverts, guys. I've turned off adverts because I just want to be able to do this with nothing going through. Wow, there's some amazing messages here. And I'm hoping if you're all saying it was good, it wasn't a waste of your time and a waste of £15 as well, because I know you work hard for this kind of, you work hard for your money, or parents work hard for their money. So yeah. Unrelated, but I'm going to do an extra video for decision 1 on the 20th. Oh my gosh, and another donation. That is very, very kind. What does the AED even mean? I'm not even sure what that means. I'm probably not going to be doing a decision session, I'm afraid, for this. I'm not going to be doing the decision method for this. Okay, so parametrics. There are 2 things we need to know for parametrics. We need to know how to do parametric differentiation, which is just dy by d theta divided by dx by d theta. And then parametric integration. So normally we do y with respect to x. You've heard me say this loads and loads of times before. We change it to dx dt dt or d theta d theta. And we make sure that the limits are the t limits that we have for this kind of thing. So do make sure you are definitely using parametric, this form that we have of integration, if you're doing parametric integration. I don't like putting things in Cartesian unless the question tells me to put it into Cartesian. So 2020 paper 2, we have this curve with these parametric equations. It says the region R shown shaded in figure 3 is bounded by the curve in the x-axis. Show that the area of R is given by 0 to pi over 2, 60 sine t cos squared t that we have here. So it's just worth checking. Obviously, the x coordinate, when it starts off, when t is 0, x is 0 and y is 0, so that we know here at this point t is equal to 0, and when t is pi over 2, 6 sine pi over 2 is 6 times 1, so that's why this coordinate here is 6, but this is where t is equal to pi over 2. Now, if they ended up being the other way around, you might actually see it in a completely different question. You might get pi over 2 here and 0 over here. If you have it that way round, when you do the limits, you would put pi over 2 on the bottom and 0 on the top, which feels very, very strange to have the limits the wrong way round. But you can change it so that if it was this kind of thing, we just talked about this, but you can change it so that it would be minus f of x, and you can put the limits between 0 and pi over 2 like this, and you just negate the function that you're integrating. However, all of that stuff that I've just been saying is not needed in this question because they are the correct way round, or not the correct, but the typical way round, that it goes between 0 and pi over 2 like this, okay? Sometimes you might need to change it because the question had like a show that the area is this. Maybe if in that other example I was just talking about, if you had the pi over 2 and the 0, you would have minus 60 sine t cos squared t. So you would need to flip them and remove that negative. So if it's a show that question, it is important. Okay, let's go back to blue. I don't know why I'm working in purple here. So x is 6 sine t. Y is 5 sine 2t, and we're going to be integrating just between 0 and pi over 2 because that's just obviously what the limits are going to be for this. I personally don't like to apply the double angle formula just yet. I'll probably apply it afterwards so that I get, when you differentiate x, let's give myself a bit more space, that dx dt, 6 sine t goes to 6 cos t. I always think this kind of maths, if you saw this at the end of year 11, you would be like, I'm never going to be able to do this. And then here you are doing these crazy questions. So remember, we're doing y dx dt. So y is 5 sine 2t, dx dt is 6 cos t, and then we have dt like this. So this is 0 to pi over 2. 6 times 5 is 30. We then have sine 2t cos t. And I know loads of people have said this before. I don't think I've made any mistakes. No, that formula is not given that we have here. So what do I need to do at this stage if I've now got the sine 2t and I'm trying to show that it's equal to something else that we've got? I'm not doing the integration just yet. Good. Kieran has just said we're going to be doing the double angle formula for sine. Loads of people have said this. This would not be a good candidate for integration by parts for those people who suggested integration by parts. Integration by parts, better candidates for integration by parts is where you have like an algebraic part and a trig part. 2 trig parts, it's got to be trig identities. So it's 30. Sine 2t is 2 sine t cos t. And then we still have the cos t afterwards, like this. And so we've got what they wanted. 0 and pi over 2, 60 sine t cos squared t dt. And I'm just going to double check that they are written sine cos squared, because I've read in some examiners' reports, if it doesn't look exactly like this, they can sometimes penalise you with the mark. But we do have it written exactly as they have. So that was A part 1. Obviously, A part 2 is just to continue and do the integration. Now, this is where if you do further maths, you probably recognise what needs to be done for this straight away. But I think we've talked about this already. Zayan has said this. SSS is saying this that we've got as well. So we do need to do the reverse chain rule. Okay, this is where you've got to be very good at differentiation to recognise this. But this cos squared t that we've got here, I often call it like the dominant function. When you differentiate cos cubed t, you'll get something that looks a bit like this. So if I write it as cos cubed t, I'm just going to differentiate cos cubed t for a second and see what happens. I would pull the power down, I would reduce the power by 1, and I would also multiply by the derivative, oh, it's under the thing. I'd also multiply by the derivative of cos, which is minus sine t. So what do I need to put at the front of this cos cubed t to adjust it so that instead of it differentiating to this, it differentiates to this? Almost. I think Ruby is the first one who said this. There needs to be the minus 20, and I'll show you why this then works. If there is the minus 20 here, I'm now going to differentiate that. So if I differentiate minus 20 cos t cubed. Well, I will pull the power down. I will reduce the power by 1, and I'll multiply by the derivative of cos, which is minus sine. The 20 and the 3 is the 60. The negatives cancel, and you have the sine t cos squared t, which is the thing that we were aiming to get it to differentiate to. Okay? So, we have done the integration correct. This is the question I think people would come out of the exam and you'd be like, the people who like integration are like, that one was good. People who don't like integration will be like, oh no, I had no idea what to do for this kind of thing as well. So I've actually done the integration, so I don't know why I've got those limits around like this. So very silly of me there. I've already done the integration, so I'll go straight in and substituting. So this is going to be minus 20 cos cubed of pi over 2. Minus 20 cos cubed of 0. Well, that's just 0, and that's just going to be minus 20. So the answer is just 20 for this, and I think it was actually a show that question. It says, hence, show by algebraic integration that the area of R is exactly 20 in this case. You cannot do by parts for this kind of stuff, okay? Lucy says, when do we have to use the other trig formula, which you rearrange with the tan in it, so it goes to a half of stuff? I think maybe that's not answering your question, but if we had something that was like this, if the question did not have the sine t there, if instead it was 60 cos squared t dt, we have to use an identity on that, okay? We have to use an identity on that kind of stuff, where we would do 60, a half plus a half cos 2t dt. The reason we were able to do the reverse chain rule here was because of this very good sine t, because sine t gets produced when differentiating cos cubed. So it was good that it was there as well. TG Tyrant, yes, you can just memorize the proof that cos squared t, the fact that cos squared t goes to a half plus a half cos 2t as well, okay? So we haven't finished, unfortunately. How much have we been? We've done an hour, so we are probably going to be about close to 2 hours for this. It then is a 5-mark question. Part of the curve is used to model the profile of a small dam, shown shaded in figure 4. Using the model and given that x and y are in meters, the vertical wall of the dam is 4.2 meters high, which means I know something about these things here. I know that their y coordinates are 4.2 because they're 4.2 above. And there is a horizontal walkway of width mn along the top of the dam. Calculate the width of the walkway. So what I'm going to try and do is I'm going to try and find out what their x coordinates are. If I can find out what the x coordinates are, then I can subtract them and then figure out what the distance is between them. But the key thing I've noticed is that the y coordinates are 4.2 that we've got here. So Doritos King has said this. They're going to find the values of t where y equals 4.2 and substitute that into the x equation. So here is y. I'm going to make that be equal to 4.2. Notice how we're keeping it in parametric world the whole time. So when y is 4.2 and also y is 5 sine 2t, we're just going to solve the equation. 4.2 divided by 5 is 0.84. So 0.84 is sine 2t. And I'm going to solve this equation. Remember that t is between 0 and pi over 2. Okay, 0 and pi over 2. So I will do, in radians mode, the inverse sine of my answer. So that 2t is 0.99728, blah, blah, blah. And for the second answer, I will do pi minus the answer. And when I do pi minus the answer, I get 2.144309, which means that my values of t are, when I divide by 2, this, and .4986, blah, blah, blah. So those are the t values that correspond to this. Oh my gosh, first class maths, that is so kind of you. First class maths. I actually think we messaged back on Twitter like a couple of years back. I would love to get back in touch with you and hear how things are going. First class maths is like the go-to person for everything with GCSE. And I know that you've been having a bit of trouble with stuff with YouTube recently. Have you got that fixed? I'd love to know if you've got that fixed. Because first class maths is absolutely exceptional YouTuber and brilliant in the maths community. So that's so cool that you're here. Thank you so much. That's so kind of you. Oh, I'm so happy. This is what happens. I get these messages, I get distracted from the maths, but I don't mind it because it's all for lovely reasons. Yeah, do get back to me on Twitter. I'd love to kind of catch up and hear how things are. So we're going to find out the x coordinates, and x is 6 sine t. X is 6 sine t. So I'm just going to figure out what x is equal to for this one and for this one. 6 sine that one, that's 2.8693 meters. And for the other one, I will do 6 sine 1.07215, and we get 5.2693. So the coordinates that we've got are those two values I've just calculated, is this one and this one. So I'm going to subtract them to find the distance of that walkway along the top that we've got there. That was so cool that First Class Maths is here. I hope you guys used him for GCSE. He makes the most amazing papers. Like, he doesn't call them predicted, he calls them expected papers, which is exactly the kind of stuff that I'm talking about here. These are the topics we are expecting. We can't predict anything because we don't possibly know. So the MN distance is 2.40 meters to 3 significant figures. To get that, by the way, I did the 5.2693 minus the 2.8693 as well, and that gave me the 2.40 for this question that we've got here. Really, really, really weird question that we have. Oh, it's nice seeing like how many people have liked the First Class Maths comment as well. The super chat. That's really cool. Okay, so we did get this. We got the show that part. This was also a show that part, and there's those 2.4 meters for this bit as well. Now, this is where I'm going to just have to do a little bit of promoting some of the things as well. You know that I won't be doing like a live session. I wasn't subbed for. That's so funny. Oh my gosh, you've done another donation. That is crazy generous of you. Let's message on Twitter to First Class Maths, and now you've been subbed for an hour. That's good. Okay, I was going to say, for paper 3, I will be doing some lives. I will be doing some lives that are just on YouTube, but they'll just be from past paper questions. I'm not going to be doing a live Zoom session for paper 3 because those have already happened and nothing will be different about those sessions. But the recordings of those are available immediately. £15 for mechanics, £15 for statistics, and they will just be great revision of covering everything that you need for those bits for applied. The reason I'm not doing another live session for it is because I just think getting recording and using it at the time that's convenient for you. You can get it now, you can get it after the exam, you can get it the day before the exam, whatever you need. Everything is linked in the description. People like my sessions, which I am incredibly proud of, and I'm very, very happy that people have liked my sessions and found them useful. It's like a dream come true to do this kind of stuff. So functions, there is tons of stuff to do with functions, but at this stage, when we've been on for an hour, I don't want to be doing like really heavy stuff for the end of this. Let's see how much we've got left. So we're at functions. We've got functions, mod graphs, geometric series, and recurrence series. Okay, that's not bad. We're not doing bad at this stage. We've done 5. We've got 4 to go. Now, in case I can save you some time, if you've been in any of my other lives or any of my other sessions, you will know this little trick that I like, is that if a question asks you something to say, I don't know, find f inverse of 2. Now, what people normally do is this long process. What they do is they find the inverse function, and then they sub in 2. This is a long process. Don't do this, okay? Do not do this. Yes, it's £15 each. £15 for mechanics, £15 for statistics, because they're long sessions. So what you can do is instead, I can say, let's let that be equal to x, and then we can do this little trick where we switch the input and the output, and we switch from f to f inverse. Either way around, it will always work, so that we can say that f of x is equal to 2. Similarly, if I had something like f of x is equal to 4, I could say that f inverse of 4 is equal to x. Swap the input output, go from f to f inverse with this kind of thing that we have, okay? So the other stuff is, classic things like domain and range that we have here. Oh my God, that is, what is this? The AED. Is AED, like how much is AED? That's very generous. Unless it turns out like AED is like 10B. I don't know what AED is. It must be something else. That's very, very good. This is crazy. It's... Okay. Amazing. It's very, very kind though. It's very kind for people to kind of be giving anything at all. Like, I do not expect that. This is just a live stream I do because it's just really fun for me to do these live streams. And I hope if you get to your exam tomorrow and you're like, oh my gosh, that session with Mr. Bicen helped, or the in-between session that I bought from him helped, that's like incredible for me. So F to F inverse, we know that domain and range just switch places for these kinds of things as well. This is great. Okay. So here is a question from 2020. I haven't done a very tricky one for this one. In the other sessions, I've done harder ones. I needed to try and have some things that were really hard in this session, and then some things that were a bit like easier. And obviously I saw in the chat, people were like, this parametric question is tough. People do find the parametric stuff. Okay, I will answer that question from Fave in just a second about finding the range of f of g of x questions. When we get to the end of this section, I will be doing this as well. Okay, so remind me in case I don't answer that person's question, because that's a good one to talk about. So let's hope if it comes up as something like question 4, it's going to be really straightforward. Instead of trying to find out what this is equal to, so trying to find out what x is, I will switch places and change it from f inverse to f. So this question now becomes really easy. It's just solve an equation that f of x is equal to 7. We never even needed to find out what the inverse function was. So 3x minus 7 is equal to 7x minus 2, which is 7x minus 14. So I will add the 14 onto the left-hand side. Minus 7 plus 14 is 7. I will subtract the 3x. And so x is equal to 7 over 4, which just means that f inverse of 7 is equal to 7 over 4, okay? And then for the next part, it is a composite function. So we're putting the f function inside the f function. And I really wanted to do this question to kind of show you how I would sort of simplify these kinds of things that we've got here. I think to the person who's done the super chat for that, I think actually when I go through that question, I actually think I make a mistake at the beginning and then I correct it during the session as well. Okay, so I do correct it later on in the session, I think. So we're going to do f of x. I'm going to write down what f of x is so that I don't make any crazy mistakes for this. Now this literally means everywhere there is an x, I'm going to be substituting the whole thing into it, which is such a strange kind of, it's like Inception. I don't know if anyone's even watched the film Inception these days, but it's like a function within a function and we're just sort of like substituting in. It's like a dream within a dream. So anywhere there's those little highlight x's, I'm going to replace with a 3x minus 7, a 3x minus 7 over x minus 2. So that's going to get multiplied by 3 and subtract 7. And then where there's the x in the denominator, that's going to be a 3x minus 7 over an x minus 2 minus 2. Now this is really messy kind of stuff that we've got here. So I think there's something very simple that we can do to the numerator and the denominator with this kind of thing. What can I do with the numerator and the denominator that's like a simple way of going through this? What's the most simple way of going through this? Good. I can multiply the numerator and denominator by x minus 2. If I multiply everything up here by x minus 2, and if I multiply everything down here by x minus 2, I haven't changed it. It's multiplying by 1, right? So if I do this, this will just be the first part will get multiplied by the x minus 2, so it just disappears. So that's 3x minus 7. And then there's the minus 7 with the x minus 2. Notice how it has to get multiplied to both things because there's this subtract sign here. And in the denominator, multiplying by the x minus 2 cancels this out. So I get the 3x minus 7. And there's the minus 2 getting multiplied by the x minus 2. And then it's just simple stuff. (3x minus 7 minus 2x plus 4). Don't make that silly mistake. Numerator is 2x minus 7. Denominator is x minus 3, which is what they wanted. So we had the 2x minus 7 and the x minus 3. So in this case, a is 2 and b is minus 7, but you don't ever really need to say that written. You can just write it in the form that you've got there. So we do have the 7 over 4 and the 2x minus 7 over x minus 3. Now, someone earlier on asked about what do you do if you're trying to find out the range of f of g of x. Well, what you do, you start off, you use the domain of g to find the range of g. And because g is inside f, the range of g becomes the domain for f. In other words, the output that you're getting from g is the thing that's being input into the function, so you then use that information to figure out what you can then get out of the function. Now, there are some more complex versions of this, but they tend to not be the kinds of ones that they've asked about in the exams. The ones that get asked about in the exams are a lot more kind of simple, where you just find out what comes out of g. What comes out of g is what's going into f, then you use that information to figure out what is coming out of f for that last part, okay? So, is there anything else that I've missed on this stuff? I don't think so. And also, it's like a 1 mark. If you're going to spend like 20 minutes on a 1 mark question, you're not using the right exam strategy. You want to try and do some other kinds of things for this. Modulus graphs. I actually love modulus graphs so much. Modulus graphs. I don't know if anyone's noticed this. I think I might have talked about this a bit in my in-between session. But I started really noticing a lot of similarities. I wonder if anybody who was in my session, what did I notice about similarities of modulus graphs and then another kind of question, particularly when finding the vertex. There was another kind of thing that I talked about for this. Very good from D dot. Yeah, D dot, I talked about how it looked kind of similar to like the completed square kind of form that we have for this. So when we're ever looking for like a turning point of a graph, it's like if this was something like, I don't know, this could be like y equals the modulus of x plus x minus 3 plus 2. What is this point? What is the vertex of this point that we've got here? Doesn't seem like it's lagging for anyone else. Good, loads of answers to this. It's 3, 2, and actually it is 3, 2. If I wrote an equation like this, y equals x minus 3 squared plus 2, it would be like the same thing, apart from it would be like this kind of shape. So it's that same concept of finding the turning points from modulus graphs, and then obviously this one is the quadratic. When we are looking for anything to do with ranges of values, the vertex is the most important thing in these questions. So they often ask about the vertex, and then we go from here, okay? So we've coming up to about an hour and a half, and I usually aim for these to be about an hour and a half, so I'm not going to spend too much time on that theory. Let's go straight through and have a look at this one. So figure 2 shows a sketch. I put it down here. Y equals 2x plus 4 modulus minus 5. Find the coordinates of P. Well, that's really easy from that information I just said. It's going to be minus 4 minus 5, because that needs to be as small as possible. When it's as small as possible, we get minus 5 overall. So it's minus 4 minus 5. If you have other methods for this, that's absolutely fine. Minus 4 minus 5 also makes sense. It's in that quadrant down in the corner. If it's, well, down in that corner, I should say. So if it's in that corner down there, it makes sense that they're both negative for this kind of thing that we've got, okay? Then it says we're going to solve this equation. Now, I often, if you watch my original playlist of this, I'm like, you should draw a sketch. And when you draw the sketch, it will tell you where they intersect. Sometimes I can't be bothered to do the sketch for this. Now, it's a 2-mark question. Because it's a 2-mark question, it's telling me that there's only going to be one solution. I know I shouldn't like break the rules like this, but if they're asking to do a double solving, it's not going to be 2 marks. It's going to have to be a 3 or 4 mark question that you've got. So this is going to only cross with one of the branches. Now, if I was to draw it, 3x plus 40, it's probably going to be somewhere, gosh, all the way up, really, really high up like this. And it's going to be steeper. I don't know which of them it's going to cross through. So I'm going to just be like, you know what? I don't know which one it crosses through. I'm just going to solve them both and see what happens, which is annoying. So if I take the positive version of this, it would be 2x plus 4 minus 5. 3x plus 40 equals 2x plus 8 minus 5. Subtracting the 2x means I just get x equals 8 minus 5 minus 40. 8 minus 5 minus 40, which is minus 37. Now, maybe you're better at this than me to know if this is going to like intersect with it or not, but I guess I can tell now it is not going to be intersecting, because if it's intersecting, we're talking about the 2x line, which is this branch that we've got here. It's telling me that it's intersecting it when x equals minus 37. Well, it can't intersect when x is minus 37 because the line only exists when x is greater than minus 4. So that one's not going to be valid. Now, what you can do to check if it's not going to be valid is you can take x is minus 37, you can substitute it in here, and you can substitute it in here, carefully doing the modulus signs. And if it doesn't give the same value, then it is not valid. This one is not valid because it's crossing somewhere all the way over here, and it's not crossing over here with the green line. So that one is not accepted. Someone said to dash it in the calculator, which is also another approach. So the one that is going to be valid is the 3x plus 40 being equal to, I'll put the minus now outside the front, so it's going to be a minus 2x plus 4 minus 5. So 3x plus 40, this is where the 2 marks are actually coming from, right? So the 5x is equal to minus 8 minus 5 minus 40, which is minus 53. And minus 53 divided by 5 is either minus 53 over 5 or minus 10.6. And that one feels good because minus 10.6 is going to be somewhere over here, and it's talking about it crossing this other branch that we've got for this one. Okay, how many people have voted on that thing that we had at the beginning? 3,968 people. If you haven't voted, guys, on which mantra it's going to be for paper 2, please let's get to over 4,000 votes. That would be absolutely amazing to kind of see what we have for this, okay? Cool. Let's do the last part of the question, which says a line L has equation y equals ax, where a is a constant. Given that L intersects the modulus graph at least once, find the range of possible values of a, writing your answer in set notation. So we have a line that is going to be something like this, and it's going through the origin. I wonder if this is going to work. I don't know how to use this new version of it. No, let me try this one more time so that it might be a bit more useful. Okay, so why is it not letting me do that? Here is the line, and we're saying it's going through the origin like this, and we're trying to make it cross the curve at least once, okay? So I personally think I'm going to find it a bit easier to say when it doesn't cross at all. Okay, when it doesn't cross at all, and then the opposite of that will be it crossing at least once. So it's not going to cross when it is parallel to the branch that's on the right hand side, like that kind of branch. It's not going to cross when it's parallel to that one. And it is going to cross when it's going through the vertex of the other part. So not crossing will be in between these two values. The other set will be when it crosses at least once. In other words, it's going to cross it when the gradient is steeper, and then all the way for these negative gradients, it's also going to be crossing until it gets to this bit. So I personally find it easier to kind of do when it's parallel and then when it's going through the vertex. And then we're going to do the opposite of that part that we have there. So for part C, I'm going to do the opposite. I'm going to investigate no intersections. No intersections. Well, that's clearly going to be when it has the same gradient as this branch. What is the gradient of this branch that we've got here? What is the gradient of that branch? Because I'm thirsty and it gives me a chance for a sip of water. Oh, careful what the gradient is of that bit. Good. The gradient is 2 for this part. So there is going to be no intersections when A is equal to 2. Or if it's less steep than 2. So I'm going to say that A is going to, oh, not A, yeah, A is less than or equal to 2. There is also then one intersection. Maybe I'm overcomplicating this, but I find these bits a bit mind-bending for me. When it goes through the vertex, and the vertex we said is minus 4 minus 5. And y equals ax. So I can substitute those in. Y equals ax. So a is equal to 5 over 4. The negatives cancel. So there's no intersections when a is less than or equal to 2 or greater than 5 over 4. Because if it's steeper than 5 over 4, there's no intersections. So this means that the opposite must be true. that at least one intersection, I think I'm overcomplicating this, so maybe you'll have better ways of answering it, will be the opposite of this. Instead of it being less than or equal to 2, between 5/4 and 2, I would say that A is going to be greater than 2, or A is going to be, instead of it being greater than 5/4, it would be less than or equal to 5/4 for this. Hard stuff for this part, but it did ask for set notation. So in set notation, it will be A such that A is greater than 2, or A such that A is less than or equal to 5/4, okay? Now, they never seem to type these less than or equal to signs very well, but that is supposed to be a less than or equal to for that part in the mark scheme. So we had the P is -4.5, and we had -10.6, and then that other part. Do we have -10.6? Yes, we did. I think that part was really hard for this. So how do I know if it's less than or greater than? So if A was at least one intersection, means that A has to be steeper than 2, because if it was equal to 2 for this purple line, there's no intersections. The second it goes steeper, it's crossing the green line. And then for the other part, when it is going through the vertex, there is one solution. But if the gradient gets even more shallow than that, then there is at least one solution. So that's why it's allowed to be equal to the 5/4 or less steep than it. It's very, very hard for this. Okay, someone's saying, imagine if everybody donated £1. You don't need to donate anything. Like, you come into these things, it's just because I like to help people with maths, and plenty of people are like coming to my sessions and paying for those longer sessions as well, which I'm very, very grateful for. But honestly, when I became a maths teacher, I never thought I would get to teach 2,000 people at once. 2,000 people who, from their own accord, are wanting to watch me in a silly Bicen t-shirt. Like, I thought I was going to be teaching like 20 people before the exam, and half of them probably wouldn't even want to be there. So feeling very, very good. Okay, we are on to the last 2 questions, and then I'll do a bit of a Q&A at the end, which is going to be good timing for this. Geometric series, there's tons of stuff that's in the formula booklet for this. I think the question I've selected is potentially the kind of thing they might do, because the arithmetic series question that we had in paper 1 was not modelling. So I think there could be something to do with modelling like this. By the way, when I said silly t-shirt, I do love this t-shirt, but I mean, obviously it's like, it's not serious, right? It's not a serious one. So geometric series, I'm not going to do too much writing with this. I think there's lots of stuff in the formula booklet. I will write this down because I always forget it, but I think it's a 1 minus r to the n over 1 minus r, and the sum to infinity is a over 1 minus r. But I think I might need these in some kind of question, okay? A competitor, you've probably seen this question because these are from like past paper stuff. Oh, thank you very much, David. A competitor is running a 20-kilometer race. Oh, I've got to do so much reading in this question. She runs each of the first kilometers, 4 kilometers, excuse me, at a steady pace of 6 minutes per kilometer. You can see I'm getting tired because I'm not reading correctly. After the first 4 kilometers, she begins to slow down. It's like the same with me. After the first 7 questions, Mr. Bicen begins to get bad at maths. In order to estimate her finishing time, the time that she will take to complete each subsequent kilometer is modelled to be 5% greater than the time she took to complete the previous kilometer. Makes sense. She's going to be doing 6 minutes per kilometer for the first 4, and then afterwards her time is going to get longer by 5% for each kilometer. Using the model, show that her time to run the first 6 kilometers is estimated to be 36 minutes and 55 seconds for this. It says my chat has disconnected. What is going on here? I'm going to just check with my moderators and see if anything has happened for this, because maybe something has dropped with my, maybe something has dropped. So I'm going to just quickly check with the guys who do my moderating. Am I still live? Because if so, I will just keep going, but it keeps saying that my chat has been disconnected, which is very, very unusual for a YouTube live. Okay, good. So the chat on my end is not live. Okay, so I probably can't see anything in the chat at the moment because it says that on my maybe I'll just refresh it and see what happens. Sorry guys for this disturbance. Let's see how we're going. Uh-oh. Maybe my computer's dropped off the internet. Anyway, I'll just continue. I can't see any of these super chats or anything, so I feel a bit bad about that. But it's kind of jumped out. Let me see if I can just grab it from the studio, and I'll come back in just a second, guys. So while I'm doing that, people are saying that you can still see me. We're going to show that, sorry for this disturbance, for the first 6 kilometers. Well, the first 4 kilometers is going to be 6 minutes per kilometer that we've got. So the 5th kilometer will be 6 minutes, but increased by 5%. We know that to increase something by 5%, we multiply it by 1.05. And for the 6th kilometer, it'll be 6 minutes times by 1.05 squared. This should remind us of when we do things like compound interest that you would have done at GCSE. So I'm just going to get this all typed into the calculator. For some reason, my other laptop, which I use to do the keeping an eye on the chat, is just having an absolute meltdown. So I'm going to restart that whilst I'm just using my MacBook, and hopefully it will still be fine, okay? So that's going to be the 4 times 6, that's the 24, plus 6 times 1.05, plus 6 times 1.05 all squared. And that gives me 36.915 minutes. Now, they've asked for it to be in minutes and seconds, so I'm just going to do the 0.915 of the minute that we've got there. I'm going to multiply that by 60 to get it in seconds. This is very strange because I can't see the chat. I can't see anything that anyone is saying, which is 54.9 seconds. So in other words, it is 55 seconds. So we have the 39 mins, 55 seconds. And then this is one of the weirdest parts of questions. I'm just going to quickly see if I can get my other laptop working for a second. Okay, then I can open this up. See if YouTube wants to play ball. I have like I don't know if you've probably not done a live before, but when you do have a live, it has like a control room and you can see everything that's going on. So let's see if my chat is back and I can finally see everything. Amazing. Okay, I'm back. And I can see everything that's going on in the chat that we've got there. And I can see lots of people have done some super chats as well to all of those people. So I'm back. Did I do something wrong in this question? You said it's 36.915. It's not, is it? It's 39. So 4 times 6 plus 6 times 1.05. I'll fix it now, guys. I found that quite stressful and I was trying to keep a cool head. Yeah, it's 36.915. Thank you very much. And I probably should have noticed that, but I was so stressed trying to reset my computer that I didn't notice what was going on there. Okay. Oh my God, Tommy, you don't need to do any of these super chats. It's very, very kind of you guys. You don't need to do any of this stuff because it's just absolutely, I just want to do this for fun for you guys. Okay. Well, not fun, for revision. This is definitely not fun for you. Okay. Okay, stop. Stop doing all the donations. Let's actually finish this off. Show that her estimated time in minutes to run the rth kilometer with r between 5 and 20 is this thing. Okay, let's just investigate. So they've said that it's for r between 5 and 20. Let's investigate r6, r is 5, r is 6, r is 7. Well, we just said for the 5th one, it would be 6 minutes multiplied by 1.05. For the 6th one, it would be multiplied by 1.05 and then multiplied by 1.05 again for that part. So the 7th one is going to be cubed. The 8th one would be to the power of 4 like this. And so then, and we've got more people donating with AED currency as well. Amazing. So now we just need to say what the pattern is. So I'm just going to write this down in words. The power of 1.05 is 4 less than r. Look at it. 5 power of 1, 6 power of 2, 7 power of 3, 8 power of 4. Hence, this means that the rth time is 6 times 1.05 to the power of r minus 4. 4 less than r for this. Very, very crazy sort of weird sort of question for this. So many people, this is so cute. You don't need to do any of these donations. Honestly, I'm so happy just running this session just for fun. So you don't need to do any of this, okay? It's very kind. Please don't do it. So the estimated time we've done, we're now going to do the total time in minutes and seconds that she will take to complete the race. So part C, the first 4 kilometers we already know is 4 times by 6 minutes, so it's going to be 24 minutes. We're now going to do the last, if I can spell last correctly, the last 16 kilometers. So for the last 16 kilometers, it's a sum of a geometric series because each time it is multiplying by the same thing each time. I'm trying to basically add up all of these terms. So the first term that we've got in this one for 5, 6, 7, and 8 here. Oh my God, you guys, there's so many people doing them. It's very kind of you. I don't know why I'm saying not to do it. It's nice of you to do. I'm appreciative. So for the last 16 kilometers, there are going to be 16 terms. The first term, though, because we're starting at the 5th kilometer, is going to be 6 times by 1.05. And the common ratio is 1.05. So it's just going to be a sum of 16, which is going to be A. If I remind you of what the formula is, or really reminding myself, A 1 minus R to the N over 1 minus R. A multiplied by 1 minus R to the N divided by 1 minus R. And this is where I hope I can type some things into the calculator. Why are people asking if I'm going to shave my head? We know I'm not going to be shaving my head, especially as I've already talked on other lives that my hairline is not doing its best work. I am now 36. My hairline is not the best hairline in the world anymore. It's not like when I was your guys' age and I actually had hair. So this means that the total time is just going to be the 24 minutes for the first 4 kilometers plus the 149 minutes like this. So it is 173.0421981 minutes. But they wanted it in minutes and seconds. So it's going to be 173 minutes. On my calculator, I'm going to be doing 0.0421981 times by 60 to get the seconds part for this. And that is 2.53 seconds. So to the nearest second, 3 seconds for this part that we've got here. Okay. Oh no, there's a fly that's just come in through the window. That's going to annoy me so much. Oh my gosh. No hat today, just Bicen t-shirt instead. We are finally on to the last question because we do have the 173 minutes and the 3 seconds. We got the Arth turn formula here, and we were doing that show that for this beginning part of the question as well. Thank you to absolutely everybody who has done a super chat. It's really put a smile on my face when I'm doing this non-monetized stream. It's just it's nice for you guys to do that. It's very, very kind of you. So we're going to finish with recurrent series. Now, my tip for this is always just find out what's going on in the recurrent series. Just kind of do some of the like substitution into the recurrence and see what happens. Often we talk about things being periodic. How would you describe what periodic actually means in this? And I'll tell you about the difference between this one and a geometric. Doing a stream for charity is a really good idea. It means it repeats, right? It means it repeats. And I like Sophia, she's done an example of 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. It's just a series, a sequence that is just like repeating. Saki has done so many of these super chats, and we've got loads of people doing this, and Mubarak as well, who's also a member of the channel. Thank you so much. Periodic is a repeating sequence. So let's actually just dive in with the final question of this session, and then I'll do a bit of a Q&A, and hopefully just leaving you guys feeling prepped and ready for tomorrow's session. So this is a 7-mark question. A sequence of numbers A1, A2, A3 is defined by this formula where k is a constant, and it tells us the sequence is periodic, sequence of order 3, and that A1 is equal to 2. So what is A1 going to be the same as? What number will it be the same as if it is periodic order 3 for this one? What is it going to be for this one? Careful, it's not going to be A3, it's going to be A4. Let me just demonstrate to you why it's A4. So if a sequence is periodic order 3, let's pretend it goes like A, B, C. A, B, C. This is the first one. This is the fourth one. So it's the first one is going to be equal to the fourth one. Sometimes drawing yourself a little extra diagram in the question can be useful because you can suddenly go like, oh, I know what to do. People are sending some memberships. This is so cute. This is so nice. So this is all I'm going to do. I'm going to find out what A4 is, and I'm going to make it equal to 2. So my formula is that AN plus 1 is K lots of AN plus 2 over AN. Now, if you're not sure how to use this formula, I'll show you. So A2, here this is 2, that means that n is 1. So anywhere there's 1, I'm going to replace it with A1 like this. And I already know what A1 is. They told us in the question that A1 is equal to 2. I'm going to keep track of them up here so I can use them during the question, okay? So A2 is going to be, it's like the f of x question we did where you're kind of substituting things in. It is going to be 2 plus 2 divided by 2. That's 4k over 2, which is 2k. So A2 is equal to 2k, just in case I need it. A3 is going to be, using this formula, you're using k lots of the previous one plus 2 divided by the previous one, okay? We've got some people donating in Turkish. Is that Turkish lira? TRY. Hang on, is that in Turkish? I'm not sure. I'm probably not going to be doing something for FP2, I'm afraid. I don't think I'm going to be doing anything for FP2. So the k's cancel, and I have 2k plus 2 divided by 2, which is just k plus 1. So A3 is k plus 1 that we have for this part. And then we're going to continue and say that A4 is k lots of the previous one plus 2 divided by the previous one. What a terrible fraction line we've just drawn there. Let's fix that, which is k times by k plus 3 over k plus 1. No simplifying can be done for this, but I know something. K plus 3 over k plus 1. We said something earlier on. We said that A1 was equal to A4. So let's do that. That means A1 is equal to A4. I'm going to multiply up by the k plus 1 that we've got here. People are sending memberships. Guys, I was never expecting any of this kind of stuff. This is so cool. I love it. So I'm going to multiply it by the k plus 1. And I'll expand the bracket, so I get k squared plus 3k. I think I've done a classic thing. I don't even think I've read the question again. This is absolutely classic, what I do. I don't read, I just do maths. So I get k squared, 3k take away 2k is k, and nothing minus 2 is minus 2. So we get k squared plus k minus 2. Yeah, it was a show that question that we had here. It then says, for this sequence, explain why k cannot be equal to 1. Okay, so I'm going to just very quickly grab this thing here. I will copy this. I'm going to paste it on the next page. And we're going to investigate what happens if k is equal to 1. So, I knew it wasn't going to let me paste it. Let me try it one more time. Copy. What is wrong with me? Am I not doing something right? There we go. Now it's finally copied it. Paste. If k equals 1, A1 is 2, A2 is 2, A3 is 2, A4 is 2. If k equals 1, the sequence is not periodic, order 3, so k cannot be equal to 1, okay? This is so fun. I don't know how those gifting memberships, I've never seen that happen before. So for this sequence, explain why k cannot be equal to 1. And then we're going to find this thing between 1 and 80 of AR that we have. So I actually think we didn't really finish off this part that was in red up here that I'm going to highlight in yellow. I'm actually going to solve that equation. It was like a whole point of doing this was to solve the equation. So for part C, it was k squared plus k minus 2 equals 0. Now, obviously, I don't need to. I'll tell you what, I'm not even going to use my graphics for this. I'm just going to factorize it. So it's a k plus 2 and a k minus 1. So either k is equal to 1 or k is equal to minus 2. But we've just said k can't be equal to 1. So k is equal to minus 2. Now, if k is equal to minus 2, thank you, CMart Emmy as well. If k is minus 2, I can now find out what all of the things are in the sequence. So it goes, A1 is 2, A2 would be minus 4, A3 would be minus 1, and I know that A4 is going to be equal to 2. So this sequence is now going like this. It's going 2, minus 4, minus 1, 2, minus 4, minus 1. And what we're trying to do in this question, I'm going to give us one final blank page for this. We are trying to find the sum from n equals 1, from r equals 1 to 80, of AR. In other words, A1 plus A2 plus A3 all the way up to A80. Now, we have to think of them as coming in groups like this. So there's going to be how many groups of, it goes 2 minus 4 minus 1. There's going to be groups of those in 3. So to find out how many of those groups that there are going to be in 3 for this, I will do 80 divided by 3. 80 divided by 3 is 26.6 recurring. In other words, it's 26 remainder 2. This means that there are going to be 26 complete sets of 3 and 2 extra at the end. In other words, the answer to this is going to be 26 groups of the 2 plus the minus 4 plus the minus 1, plus there's going to be 2 of these extra ones at the end, which is a 2 and a minus 4. So 2 minus 4 minus 1 times 26 plus 2 minus 4, and we get that the answer is minus 80 for this kind of question that we have here. Whew. Did we get it? We knew this was a show that kind of stuff. There is that minus 80 that we have. And we did all of this in 1 hour and 40 minutes, I think. I think that's probably how much we've done here. Oh my gosh, people are sending so many members. This is absolutely insane. You guys do not need to do this. All of these memberships, yeah, they've been completely given out at random. This is literally crazy. So I am going to answer some questions now. I'm probably going to go to the big screen because I want you all to see my face and my t-shirt. I hope that tomorrow you are going to absolutely smash it. I just hope these questions are going to be the kinds of things that are coming up. And not only did I go through some of these questions, which I will be linking in the description, this annotated version of it, I'm hoping that I've taught you some things in this session, or at least just refreshed some of the things that we've got here. That's really what I was hoping that we were going to be doing here, okay? Oh, that was a really, really fun live stream. The total on this live stream, people have donated, from what I can see here, it says £150 is absolute madness. You guys are amazing. I've had so much fun doing this. So do you have any questions before we finish up? I'm going to just tilt this so you can get like a good view of the Bicen t-shirt. This is all I use, by the way. I'm just using my iPad like this. That's all I'm using. Okay. Do let me know if there's any questions that we've got here. I could do a members live stream, couldn't I, as well? That's so kind. I am going to go for like a nice meal or something. Any questions for like terms of preparing or stuff? Or should I just kind of start doing a bit of a, what do we do? Like a bit of a pep talk at the end. Should we do a bit of a pep talk to kind of like finish up with this kind of thing? Thank you very much to Diana. Of course, you can name your firstborn after me, Sebastian. It's a great name that we've got here. This chat is absolutely on fire at the minute. It's like going at like an absolutely crazy speed. Has something changed about it? Has it like stopped the No, has it got slow mode on? It has got slow mode and it's still this busy. Wow. Maybe I need to change the slow mode again. And people are gifting so much memberships and things. Okay. Let's do the pep talk. Let's get ready for paper 2 because I think I've basically answered all of these things. I am going to say this one more time before I do the pep talk. If you want to get ready for mechanics and statistics, there are my £15 sessions, £15 for mechanics, £15 for statistics. If you are very last minute as a person, you can also, tonight and tomorrow morning, you can do my in-between Pure 1 and Pure 2 session, also £15. More of the stuff that's been like this, apart from with questions that you will not have seen before, excuse me, because they're either things I've written, they're like sort of versions of past papers or things from like international papers as well. This is crazy. 50 gift memberships. What does that even mean? This is crazy. Okay, so here is my pep talk for you guys tomorrow. First of all, I will be doing a reaction video, so you'll know what I think in this reaction video as well. This has been the craziest live stream, but you guys are going to do really, really well tomorrow. That first exam that you did, will have been a very nerve-wracking experience. Since then, you have gained a lot of experience. You have done other subjects exams. You have done your first maths exam. You know what it feels like to be in the exam hall. So before you go into this exam this time, you're going to have some adrenaline, you're going to have some nerves, but I want you to say to yourself, these nerves and this adrenaline is a good thing to have. They are going to be that little chemical in your brain that pushes you further, makes you work faster, makes you spot your errors, so that when you do feel that adrenaline and those nerves, it's a good thing. And you can really sort of support your friends before you go in. You're going to tell them they're going to have an absolutely fantastic exam, and it's just going to you're going to just smash the exam tomorrow. I know it because we've done so much work and so much preparation for this exam that we've got here. How do I find, I'll quickly just answer this question because someone has done a super chat, and then I'll finish off my pep talk as well. How to find the range or domain of composite functions with inverse of another function in it? It's really the same method that I described earlier on with this kind of thing. You just look at the domain and range of the thing that's going in. The range of the thing that's going in gets used as the domain of the thing that is coming out. So you are going to do brilliantly tomorrow. Oh, have you just seen here? Has anybody spotted there is a very special person who has just joined in the chat? And this might be the first time that she's messaged. Has anyone spotted who has just joined in the chat? She's probably here for my final pep talk that we've got here. It is Ros Bicen. It is the mother. The true Mama Bicen is here. And like I've said this before in live streams, when you are older and you're doing something that you feel very proud of and very successful, your mum is going to be so proud of you. In fact, your mums, or whoever it is that is your like number one carer who looks after you, mums, dads, grandparents, whoever it is, they are so proud of you for what you're doing right now and for how hard you're working for your A-levels. And if you ever think that they're going to be disappointed because you don't get a certain grade, if you are trying your best, I guarantee they're going to be proud of you. I know that I'm definitely feeling proud of you guys all for sort of, coming here and just making the energy like absolutely fantastic in this session. So tomorrow, keep yourself calm. If there's a weird, wacky question, please don't spend like 30 minutes on this kind of thing. If there is a weird, wacky question, make sure you're doing everything else perfectly, and then you have some time, you can kind of spend some stuff on that as well. And hopefully loads of things I've gone through today have been excellent preparation for you. And if you've been to any of my other sessions, everything's linked in the description. Hopefully that will be good for you too. This has, without a doubt, been the most fun live stream I've ever had. This has been kind of crazy, but also so much fun. Please let me know. I will do a poll on the channel tomorrow after the exam. Please let me know what you think of it. When I see the exam, I will be doing my reaction video as well, and telling you what I think of the paper. But I'm hoping lots of my expected topics have come up, and we're all going to be thanking each other for having that list of topics and being able to do this. When you come out of the exam, support your friends. If anyone looks upset as well, go and look out for those people, because it's a very, very stressful time. But this time tomorrow, you'll have done 2/3 of your maths A-level, and you won't need to know much pure maths anymore. Everything is just going to be focused on mechanics and statistics. Okay. People are saying, I think something's gone wrong with the chat, because people are now able to say loads of things. I think that the timeout on the chat has definitely disappeared. I will leave you this Bicen t-shirt. I probably will be doing a competition about people doing some designs for t-shirts, but I'll put that in another video soon. So make sure you're subscribed and you stay subscribed, guys. Okay. Good luck for tomorrow. Remember the mantra. The mantra that won was confidence is proportional to skill. We had 4,711 votes. I'm going to end that here. 4,711. Confidence is proportional to skill. You guys are confident. You've got the skills. You're good to go. Bye, guys. Good luck.